Hi, this is Mr. West, and today you're watching a Khan Academy tutorial on inscribed shapes. This one was requested by, I hope I'm saying this right, Lobfishla7177. So thanks for requesting this video. Make sure to request your own video in the comment section below if you need help on any particular topic. This one is talking about inscribed shapes. This is my first time doing it, so let's see how it goes. It's talking about a quadrilateral here, and the circle is O, and it's asking for the measure of D. So one thing I note right away is we have these inscribed angles here. Okay, so I'm going to try to change the color. This inscribed angle A that I'm trying to highlight, okay, opens up and touches a circle at these 2 points. Those are called chords. They're not radii because they don't go from the center of the circle. And they're significant because if it touches if this angle is like this, it's a chord, and it touches the outside of the perimeter and then 2 other spots on the circumference of the circle, then the arc it forms, which I've highlighted in green, so opens up to that arc, is double the angle measure of the inscribed angle. So this angle right here is 96. It opens up to this arc measure, which is going to be double that measure of the inscribed angle. So it seems like confusing lingo. Basically, if you have an angle that opens up across the shape, it's going to be double. It's different if it's from the center of the circle. If it's from the center of the circle, like this, it equals the angle measure. But we'll see if we have an example like that later on. But for now, let's figure out this arc measure. So this one would be, what is that, 192 degrees? But here's the thing, that doesn't really help us. The reason why this arc measure doesn't help us is because we're interested in the arc measure presented by D. So let me highlight that in red. We're interested in this angle. It's asking for the measure of angle D, which I've highlighted right there. So if that's the case, we want to trace this line. Let me erase the green because that was just an example. Okay, so we don't need it. And you can see I've labeled it right here as measure of arc UQD. Okay, so that's how you designate the measure of the arc of the circle. Oh, something else to note. In a circle, there's 360 degrees. So we'll use that information to help us because in a circle, 360, right? We'll use that to subtract and figure out some missing arc lengths. Arc measures, I should say, not arc lengths. So here's D, and then the arc formed by D is going to be this one because we have this connecting line right there and this connecting chord right there. So let me get rid of that again. That arc measure is going to be important to us. You're probably thinking, well, how do we find that arc measure? Well, a circle, like we said, is 360. So if we can find this blue one, then we could subtract that blue one from 360, and then we could find that arc measure, and then go backwards to find that angle measure, okay? So it's kind of involved. I understand why this video was requested now because it's an involved process, but it's not as bad as you think because it gives us an inscribed angle right here, okay, as it says it's inscribed. Inscribed shape means inside the circle. So this is 106. That makes this 106 degrees times 2 for that measure of that arc. So let's do that. That's 212. 212 degrees. Okay, isn't that the boiling point? Anyway, leave a comment if it is. So 212 degrees is the measure of that. So what does that make the red? Well, the red is just going to be 360 minus 212 degrees, and that's going to be the measure of that arc length. Don't type that in as an answer. So let's go ahead and do that real quick. What is that? 360 minus 212. We're going to borrow. You can just use a calculator. I'm just doing this because this is just as fast as getting my calculator. So we have, did I borrow and then carry it? I don't know if I did that correctly. Oh, that was a 10. Okay, got it. Can't read my own handwriting. So 148 degrees is the measure of this, but that's not my answer, okay? Obviously, this is not 148 degrees right here because it's not an obtuse angle. So I'm going to have to divide that by 2. If I have the measure of the arc and I want to find the inscribed angle, I have to go in the reverse direction, which is divide by 2. So 148 divided by 2, that's going to be 74, I believe, right? 74 times 2 is 148. Yep, that should be it. So I'm going to type 74, and that's how you kind of go forwards and backwards with these arc measures. Next question. Seems like another very similar problem, but maybe not. Oh, so it's asking for the arc measure of FL. So something we're very familiar with the previous problem. And it gives us that LI is 97 degrees. Okay, so a couple things here. One, it gives us the measure of angle L. Okay, that's important. So then we know that if we connect these lines, it's very important that you do this yourself, okay? So let's connect these two lines, these chords here. Okay, and then let's connect those chords to this greater arc. And then we know that it's double, so 220. There's 110, it's going to be times 2. And we have 220. All right, so that's important. The other information it tells us is LI. Okay, that's LI is 97. So LI is right here. And that's the measure of the arc. So that's 97 degrees. It wants us to find FL. That missing chunk right there. So you can see here, just from using the information it gives us, the 97, okay, that was given, and then we had the inscribed angle, 110, we doubled it to 220. You can see that the problem is very simple. We know that 220 plus 97 plus our missing length, and let's just call it, I don't know, let's just call it F, plus F equals 360 degrees, because it's a complete circle. Now we just need to, I'm going to add these two up first. So I know that 220 plus 90 is 310, so that makes it 317 degrees. And then I know that I need to subtract 317, so 317 plus my missing arc length, F, equals 360. I'm going to subtract that now, 317, 317. So I know that F, the measure of F, is going to be, what is that, 43 degrees? Okay, so the F is 43 degrees. And I'm done. Now, we don't need to divide by 2 because there's not like an angle that's inscribed here and we have to find like this one or something like that. So we're just going to type in 43 and that's it. It's just asking for the measure of the arc. All right, next question. So far, so great. Angle C is inscribed in circle O. Okay, AB is a diameter. Okay, diameter, that's important information. What is the measure of angle A? Okay, so a couple things to note. Number one, we want to find angle A. Let's identify what we want to find out. That's right here. Okay, so angle A, that's what we want to find out. It's not an arc. The other thing is we know that this is 60 degrees. Okay, so that's also important. If that's 60, then we know some other information. We're going to know, let's draw the line. We're going to know that these two chords, and that chord that I just drew, the second one, is a diameter. That's an important type of chord. Okay, but I know this arc length, that's going to be 120. I'm just going to write it down. I don't know if I need it, but I'm just going to write it down. Okay, and then the other thing is we're told that O is a diameter. So let's talk about C. Now, a triangle, we know one of the properties of a triangle is that all three angles need to add up to 180 degrees. Okay, so we know 60 is going to take it away, and then if we find C, we can take that away, and then we're going to be left with A. That's my thinking right now. So here's angle C. Okay, we don't know what it is, but I do know that, let's draw our lines here. I do know that this chord opens up, and this is going to be like this. Why is this one in particular important? Because, take a look, it's half the circle. That's a diameter that connects it. And if it's a diameter, then that means it's half a circle, and that's 180 degrees. That's always true. If you have a diameter across the circle, then the measure of the arc is half the circle, because it cuts it in half, and you have 180 degrees. Okay, so that's important. Now, we don't really care about this. I mean, actually, there's a couple different ways we could do this. We could find measure of angle C now by dividing by 2. I think that's probably the best way to go. 9 degrees. And now we have 90 degrees plus that first angle, 60 degrees, plus missing angle A, we'll call that plus A, equals 180. Okay, that's one way. The other way we could do is we could add these two up, okay, subtract it from 360 to find this measure right here, and then find A by taking that in half. It's kind of the same thing, okay, whatever way you like. I know that this is a 30, 60, 90 triangle, but this is 150, just to show you. Okay, plus A equals 180. So then I subtract by 150. Sorry, my handwriting's suffering a little bit. And I have measure of angle A equals 30 degrees. If you just recognize 30, 60, 90, even better. But 30 degrees is the measure of angle A. 30, I don't know how, I need the degree. No, I don't. Okay, last one. Angle C is inscribed. AB is the diameter. Okay, we just talked about the diameter. This is going to be useful. What is the radius? Ooh, okay. This time we're talking about lengths. All right, so this is kind of cool. This is a special type of triangle. This one you might need Pythagorean theorem. So I'm going to do this a couple ways. One, you should recognize if you're taking geometry that this is a special triangle, an automatic triangle. Okay, that's called a 5, 12, 13. If you already know what I'm talking about, proceed from here. Okay. If not, let's use Pythagorean theorem. Pythagorean theorem states that we can have a squared plus b squared, and that's going to be equal to c squared. Okay, so C would be the hypotenuse of this triangle. Now you're like, how do we know this is the right triangle? Well, you're going to find out in a second. But it says here angle C is inscribed in O. Okay, AB is a diameter. All right, and what is the radius of O? Okay, so yeah, let's just keep going, and I'll show you why. So if this, here's the reason that I know it's 90 degrees. The reason why I know it's 90 degrees is if I know this is diameter right here, then I know that's 180. We just did this in the previous problem. And if I divide this in half, this inscribed angle is going to be 90 degrees, 30, 60, 90. That's why I can use the Pythagorean theorem. You can't use Pythagorean theorem unless it is a right triangle. So it is a right triangle, so we can use Pythagorean theorem. Now I can find the length of C. And if I do this, I do a squared, that's 5 squared, plus 12 squared equals c squared. And I don't know c squared. So plus equals. So that equals 25 plus 144 equals c squared. That's 169 equals c squared. I have to take the square root to undo the square. And I get 13 equals c. So now I know my distance. This is 13, the whole thing. Okay? That's a 5, 12, 13 automatic triangle. Don't type in 13. It's not asking for the diameter. It's asking for the radius. The radius is half that distance. So I need to do 13 divided by 2. What does it give me? 6.5. And 6.5 is my radius of the circle. Okay? So just be careful with this. I mean, these are just little wrinkles. I love geometry, but it's trying to get you at every corner, okay? So 6.5 is my unit, or my units for my radius of the circle. And bada bing, bada boom, we are done. Hope you found this helpful. The same requester, I'm going to be honest, I already forgot the name, 7177. They also requested another video, so I'm going to make that video next. But I appreciate you watching this. Please comment if you have any questions, and I look forward to seeing you next time right here on Wes Explains Best.